half an hour time, 1 hour time, ready. Okay. Because of you will forget what you study also. Even a simple question, what did you learn in your training? So you will forget what you did learn also. Even myself, if I read something when I, 3 months back, 4 months back, even last year, I learned a lot of things. I read it, I completed it. Okay. Now I don't remember because I'm not doing daily, right? So I'm not doing daily study or I'm not practicing daily. Okay. So to be in your mind, so you should be, first of all, when you are learning the time only, at least repeat 1 time, 2 times, so then you will remember. And also when you got a time, just recollection of memory is always very useful to regain things. Okay, so this is entirely about networking topologies, type of networks. Okay, about your Wi-Fi router, your NIC, MAC address, IP address, how to check MAC address and IP address. Okay, and different cabling, coaxial cable, twisted pair cable, and fiber optical cables, hubs, switches, routers, modem. Also we discuss small points only, and 2 commands. One is a ping, another one is a trace RT. Also we discuss OSL layer, 7 layer, application layer, presentation layer, transaction layer, transport layer, network layer, data link layer, and physical layer. These last 3 layers we call it as a hardware layers. The first 3 layers we call it as a upper layers or a software layers. And transport layer we call it as a end-to-end connectivity, which is a out of OSL layer. And of course, there is several protocols are there. Some protocols are given a list and their reserved port numbers. Okay, protocols are used to know what type of communication. Okay, from client to server or server to client. So what type of communication? Okay, next, and know the all that what are the protocols are given, at least that protocols and their port numbers. And there is a question: is what is the difference between HTTP and HTTPS? HTTP is a what are the data you are sending and receiving is not encrypted. So HTTPS, HTTP or SSL or TLS data is whatever you are sending and receiving data is encrypted format. So if anybody catches your packet in while you are transmitting data, receiving data, so they don't get what is the content of the data. Again, application layer. So what is the application part of communication? Client side applications, server side applications comes under application layer. Like you want to access a website, you need a web browser. You want to send and receive a mails from mail client application is a Outlook. Okay, FileZilla is an application for FTP protocol we are using there for uploading and downloading your files. Same as for a server side, server. Web servers are there like a Tomcat server, HTTP server. Sir.
Sir, please unmute yourself.
Sorry. I'm muted. Yeah. Presentation layer, encoding, decoding, compression, decompression, encryption, and decryption. Session layer. So when you are sending a data, so you will first up when you send a request, session will be created, and when completely you receive a data, the session will be terminated automatically. Or any network interruptions occur, session will be terminated. Okay. Guys, whatever the data in the layers, okay, application layer, whatever the data it is, we call it as a data only. We call it as a data. PDU, packet data unit, is simply a data. Even presentation layer, encryption, compression, encoding, the data is data only. Session layer also, the session ID will be added, but still data is data only. But at transport layer, the data will be chopped, numbered, and sequencing order, and it is useful for a error correction. Means if any packet is missing, so the sequence packet will be received again based on the acknowledgement. They will order it again. Okay, so it's error correction. Okay. Multiplexing of TCP UDP, transmission control protocol, user datagram protocol. TCP UDP difference. We discussed some protocols. The protocols are either TCP type protocols or UDP type protocols. TCP type protocols are acknowledgement based, UDP type protocols are non-acknowledgement based protocol. Okay. So acknowledgement based means source knows destination received or not. How? Destination, when destination received a packet, destination send an acknowledgement to the source. So source knows destination is received a packet. That's what it is. These protocols called reliable protocol, connection oriented protocols. And also transport layer do flow control, windowing kind of stuff. Okay. The data in the each layer we call it as a PDU. To that PDU, the data which is added with this TCP header, which contains segment information, numbering, protocols, information there. So this is what we call it as a segment. This segment is sent to the network layer. Okay, so transport layer, what is the output PDU? What is data we are getting? Segment. The segment sent to the network layer. In the network layer, it is added with the network header, that is source IP address, destination IP address, any routing information, that routing information also will be added. The total PDU we call it as a packet. The packet, network layer packet. And network layer hardware wise device is router. Okay, data link layer, LLC and MAC address. Data link layer having two sublayers. One is LLC and MAC address. LLC is actually dealing with the WAN protocols. When you are communicating in the WAN, so what are the WAN connecting devices? That is router, modem. Okay, WAN communication. That time we use a WAN protocols. Normally we tell LAN and WAN, MAN, CAN kind of stuff, guys. So we are giving geographical size. Okay, originally I have a 10 computers in one LAN network, 10 computers in another LAN in the same room only. I make them communicate with the WAN protocol. Then it is a WAN communication only. Okay. So simply it is, if you follow the WAN protocols to communicate between the networks, that is a WAN communication. So we use a certain WAN protocols, that is at LLC. And MAC layer, so we know already MAC address, every NIC, okay, every NIC network interface card having a MAC address. MAC address is a physical address given by manufacturer of NIC. It is a 48-bit in number, 12 hexadecimal number. Okay, so we got a packet from network layer, and this packet is added with the data header and data tail. Data header is source MAC address and destination device MAC address plus CRC, cyclic redundancy check. It is used for a error checking. Remember guys, layer 2 data link layer, layer 2 data link layer, Error checking is happened at a data link layer. Error correction is occurs at a transport layer. Okay, this whole packet, whole PDU, we call it as a frame. CRC is an algorithm used to check the data errors. Physical layer is actually convert this frame into bit stream, and this bit stream will be converted into different form of signals, like either it is electrical signal, radio signal, or a light wave signal. Depends upon what kind of interface you use. Okay. So there is a OSI and TCP/IP comparison, guys. Comparatively, TCP/IP is a DoD model. Earlier name is DoD model. It is a defense model. So still we are using TCP/IP only. The whole world is communicating with the TCP/IP protocol suite. Lot of protocol suites are there. IPX, SPX, Novel Network, Apple Talk. Like there's so many type of protocol suites are there. So for all any kind of protocol suite we can understand with the OSI layer. This is only comparison purpose only. It's not like a TCP/IP came from OSI. That is wrong information. Just people think like that. But important is there's a straight comparison is there. Application layer, presentation layer, session layer. These three layers work done by application layer in the TCP/IP. These three layers combinedly one layer in the TCP/IP. Transport layer is transport layer, and network layer is called as a internet layer. Data link layer and physical layer comes under network access layer. You may get a doubt, like I said, physical layer is a hub because it does not understand any MAC address or IP address. Switches comes under data link layer. So which because of data link layer is dealing with the MAC address, switch understand MAC address. Network layer is example is router. Okay, why? Because of network layer can give IP address, right? Network layer dealing with the routed and routing protocols also. So router what is doing? It is doing understanding of IP addresses, packet switching, and routing. That is the things. That's why these are the example. So physical layer hub, data link layer switch, network layer router. But about NIC, NIC we have a NIC having a MAC address and physical connectivity. Okay. So it comes under network access layer. Means it's a combination of data link layer and physical layer. Okay, network access layer means TCP/IP network access layer, not OSI. Otherwise, it's a combination of data link layer and physical layer. Of course, you didn't get a doubt. I expressed the doubt. Okay. So today we'll discuss about IP address, guys. So today is 24/01/2023. Okay. So of course, discuss about it. Okay. So this is the starting. Okay. Just read, guys. Just give me 2 minutes. Sir called me. Then I will come back in 2 minutes. Okay, sorry guys. So here in generally, before we go, so generally I will tell that is we are always use TCP/IP protocol suite. We are all communicating with the TCP/IP protocol suite. The next one is we are using a IP addresses, not any other logical addressing. There are a lot of logical addresses are there, so but we are using IP addresses. Mostly IPv4, mostly IPv4 worldwide, and some private companies and certain countries using IPv6. For example, take Germany, Japan. That's just small countries, advanced technologies. So there are want to completely transfer into IPv6, they use IPv6. But IPv4 won't communicate with IPv6 directly. Means I have a device, one computer IPv4 only, another computer IPv6 only. They won't communicate each other because both are different protocols. Okay, both are don't understand each other, but we need a middle devices. In a topologies, in our LAN communication, we use a star topology. Our LAN, we are using star topology only. Of course, in WAN communication also star topology, but I don't mind what are the outside topology it is, what are the name of topology. Usually it is, we are using star topologies. In only in a SAN type of storage management or certain server rooms, server places, okay, redundancy servers. They use a mesh plus star topologies, hybrid topologies. Okay, this is what I'm trying to say, guys. Someone sending a message. Taking lot of time to load. Guys, may I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Also came.
Sir, Atish Singh present.
I noted. One more person is also came. Is that person? Rishabh Sukla. Regular people also not coming. That's the bad thing. Okay, not at all came people. Okay, see Nitin Sharma, Ashika. She came. Where is it? Okay, good. Okay, so here it is. IP addresses. Already we told about a MAC address. Okay, so then this is a IP address, guys. IP address is a logical address. First of all, it is a logical address. MAC address is a physical address. Uniquely identify a device in network. That's the definition. But when you are telling about this part, what is an IP address? Uniquely identify a device in the network. You have to tell the complete sentence. Okay, some people what they will do, it is unique address. It is not unique address, guys. It is uniquely identify a device in the network because you have a devices in the network. Each device should having a specific type of numbering. It's a uniquely identification number, not unique address. Okay, that's thing is there. I will tell how it is look like also. Okay. Remember always, guys, all communications by IP address only. Without IP address, we can't communicate. Without IP address, we can't communicate. We cannot communicate with the MAC address. We cannot communicate with the names. Compulsory, we should require an IP address. Either it is IPv4 address or IPv6 address or both. Okay, we cannot communicate with the MAC address and just the computer names or device names, domain names. We can't communicate. All communications by IP address only. Any device in network wants to communicate need an IP address. At least one IP address is required. Right? Okay. Any device, you take any device, IP address must be there. Okay. At least one IP address. A lot of people think each computer having an IP address. No, each computer having an NIC. Each computer must have an NIC to connect. Each device must have an NIC, means at least one NIC to connect in network. That is the first one. Every NIC has MAC address. Every NIC has a MAC address. Okay, this is 2 points. Already we know that one. Okay, so any device in the network want to communicate, it need an IP address. Without IP address, we can't communicate. Okay, so guys, so what is this communicate IP address? Simple to understand. If I told like this, I am telling just an example for understanding. So clearly listen. I want to talk to a person. I want to call the person. He need some name, right? So I have to call the person with a name. For example, Shubham is there. Okay, hi Shubham, how are you? So I'm addressing Shubham, right? Or maybe I want to send an email. I have to send an email. So the destination required a email ID, right? That is address, email address. Okay, you are sending a letter. You are sending a letter. There is a to address, from address. Okay, so that is addressing is important. Same way in network to communicate from one device to another device, both device must have an IP address, and there is certain rules also there. So that rules also I will tell later. But now this is the point. And very importantly, IP address and MAC address difference is important. IP address and MAC addresses differences is important. Okay, already we discussed, but I'm telling once again. IP address is a logical address. What is MAC address? IP address can be assigned by manually, means assigned manually or automatically. IP addresses never be inside your system by default, never be like that. Okay, by a lot of people believe, sir, I have a mobile phone, it is already having an IP address. No, guys, the IP address either it should configure manually or it should get an IP address from DHCP server. That is called automatically. Okay, so IP address configured either manually or automatically. Okay, like that also you can write. Two words like we can say IP address can be configured either manually or automatically. MAC address is given by manufacturer of NIC. I'll type again. Manufacturer. It is. Why I'm typing wrongly? It is not showing other. Okay, manufacturer. In IP address, guys, we have a IP version 4 and IP version 6 is there. Two versions are there. Here it is, no versions. Okay, no separate versions, only single type of MAC address. Nothing is developed in that. And IPv4 is 32-bit size, okay, in binary, and IPv6 28-bit in but this is a 48-bit in binary and represent in full hexadecimal. It's a 48-bit in binary. It is a 128-bit in a binary. It's a 12 hexadecimal number. It is. Okay. Anything you want to add? We can't communicate with MAC address. That is earlier also all communications by IP address only. IP address can changeable. We can change IP address manually or automatically or based on the network. We change the IP address. But in a MAC address cannot be changed. We can't change MAC address. Okay. So here I've written some more differences. That's it. Yeah, we have that is also there now. In IP address, we have a public type of IP address and private type of IP address we have. Okay, public IP address and private IP addresses we have. Here it is no public, no private kind of stuff. That's a public address. It is a private IP address, but works only in LAN only. So it's only one LAN. It is not even a LAN WAN kind of stuff. It is a different type of communication. Okay. So this is the IP address and MAC address difference. Guys, understand somewhat at least. Recollect your MAC address memory.
Yes, sir. Yes, sir.
Oh, then. Okay. Small diagram. Just actually not required to write any diagrams. Required. Okay. I will leave it because I'm spending a lot of time on these things. It it will delay your part. Okay. IPv4 and IPv6. In IP addresses, actually two types. One is it's a IPv4 and IPv6. IPv4 is a 32-bit. IPv4 is a 32-bit, and whereas IPv6 128-bit. Okay, so 2 to the power of 32 is a size like is around 4.3 billion IP addresses we are getting, and IPv6 is a 2 to the power of 128 number of IPv6. The total number of IPv6 is 2 to the power of 128. It's 3.4 billions of IP addresses. It is a word is there for that one. It is a decillion. Okay, it is called a decillion. Okay, you can go to this calci. And to calculate, so 2 to the power of 32. Okay, so 2. Okay, it is standard programmer set. Okay, this is the good one. 2 to the power of 32. So this is the number you are getting. Okay. 1 billion. What is how much is 1 billion is equal to? Okay. So in our system, guys, this is lakhs, right? So 429 crores, 49 lakhs, 67,296 IP addresses, because 1 billion is 100 crores. 1 billion is 100 crores. That is also sometimes question, right? You know, in our early days, people want ask question, what is the 1 million means? What is 1 million? 10 lakhs. 1 billion. 100 crores. They use a 3-0 system. So like this is 1000, right? So like 3 digits, again 3, again 3, like that they will use. We use first 3, then 2, 2, 2, like British system. Next, this is a 3.4 into 10 to the power of 38. That much big means you take 34 and 37 zeros. 37 zeros. You want to calculate, so then calculate 2 to the power of 128. So it is 38. Okay. E plus 38 means 10 to the power of. IPv6 is actually represented in a decimal format. This will write in a hexadecimal. If anybody don't know what is hexadecimal, so in the PPT I have written a hexadecimals also. Please try to get that one. Somewhere I have written like this. This is the guys. This is a decimal format. Decimal format having 0 to 9. Okay, 0 to 9 decimal format it is. So and it will be repeated like a 10, 11, 12, 19 reaches 20, like that it will go. In a binary, it's only 2 stages, 0 and 1. 10, 11, 100, 101, like this, 2 stages. But hexadecimal are a totally 15 digits, sorry, 16 digits, 0 to F. Single digit 0 to F. F completed, then only 10 will started. If 9 completed, 10 started. Here after F, 10 started. Okay, 0 to F. Okay, it's not alphanumeric. Some people say it is alphanumeric. No, guys, it's digits. Don't say it is alphanumeric kind of stuff. It's not. We are not using all alphabets. We are using A to F only. A, B, C, D, E, F. F means 15. A means 10. Octal is 0 to 7 only. So 17 completed, again it is 10. 17 completed, 20. Here it is 19 completed, 20. 99 completed, 100. But here it is 77 completed, 100. Okay. So 0 to 7 only. This is the octal system. 1 bit means 0 or 1. Either it is 0 or 1, we call it as a one single bit only. You have a 8 bits. Okay, you have 8 bits, that is called a byte. Byte. Okay, 1024 bytes. Okay, 1024 means kilo. Okay, again everything will be in the into 1024, like a megabyte or a megabit. Anything 1024 into 1024 is a megabyte. So like it will give goes gigabyte, terabyte, petabyte, everything is compared to earlier, it is 1024 times it is there. Okay. So decimal format. Example of IPv4 is 192.168. Something you can put it 10.23. Anything you can just, for example. Example of IPv6 is little bigger, and of course we can write very small way also. Okay, so you can see like just I'm putting example. It is never will look like this one, so there is a lot of differences are there. Okay, so here it is 201. One, two, three, four completed. Total 8 is there. 5, 6, 7, 8. We can do much easy like. Yeah, people think it should be same order. No, it's not. It's hexadecimal number. Okay, so how it is look like. Some just randomly I'm typing. Okay, this is the part. Next, if you see this example, guys, if you see this example, this is a IPv4 and there is a divided into 4 parts. IPv4 divided into 4 parts. Divided into 4 parts and separated by dot. Okay, divided into 4 parts means you have 32 bit. This entire 32 bit is divided by 4. How much? 8. 32 bit is divided by 4. It is 8 bit. This we call it as a octet. 8 bit we call it as a octet. I don't say bit. Okay, it's a byte. Of course, it's a 1 byte size, but we call it as an octet here. Call it as an octet. Next, so we have a 4 octets. Okay, 4 octets, and each octet octet means the size 2 to the power of 8 because 8 bits, so 256. Okay, we have a 256 value, so means one octet range is 0 to 255. Okay, in a binary it's like a in numbering system, so we have to count from 0, 0, 1, 2, 3, 4, 5 up to 255. Total it is 256. So last number is not 256, last number is 255. Means each octet, the size is up to 255 only, not more than 255. Okay. Now, how it is look like it is a, this is the first one, we call it as a first octet. The second one, we call it as a second octet. Okay, I will back to the IPv6 again, guys, but just I'm trying to go with this one, third octet and a fourth octet. Okay, so one octet, the range is 0 to 255. Okay, so guys, this is also some people will tell for our understanding. So in certain test books, W, X, Y, Z. Okay, so that is also I'm telling. Generally, I use octet names only. First octet, second octet, third octet, fourth octet. But maybe in future you see certain test book or someone's video, right? So, or maybe some question you see, there is a given a W, X, Y, Z manner. So don't get confused, guys. W means first octet, X means second octet, Y means third octet, Z means fourth octet. Each octet maximum size from 0 to 255. The maximum size is 250, not more than that one. So that's what I'm writing. Each octet is 0 to 255. So 4 octets completed. And not required this much, but for first time viewers, it is little confusion. Already you know that's no problem. But this is, first of all, the complete IP address, IPv4 address. So we are having IPv6 also, so that's why IPv4 address, the range, the total range is 0.0.0.0 to 255.255.255.255. Now first IP address is 0.0.0. The next IP address is 0.0.1. 0.0.0.2. It keep goes, guys. It is keep going like this. 0.3, 0.4, like it will reach up to 0.0.254. Then it is 0.0.0.255. Once it is reaches, what is the next IP address? 0.0.1.0. Not 256 won't come. So once 255 comes, like it becomes 0 and 1 is leading. Like after 9, 1 0. After 99, 1 0 0. Right? So same way it is. Once 255 completed, it becomes 0. It is never cross any octet more than 255. Same goes like a 1.1, 0.0.1.2. It go up to 0.0.1.254. That is a 1.255. Okay. So that is completed. Again, it will start 2.0. Like that, if you are keep going, means even I put a keep going kind of stuff. Once you are completed up to here, it is a 4.3 billion IP addresses. You will get it. And then you have to count it. Yeah. You take a paper and now done one by one, and then count it. If that is your wish. Okay. So this is also 2.1. Okay. It goes. That is. Okay. It is also going up to 0.0.0. Just I'm going with the third octet. 0.255.255. So once it is reaches 0.0. 0.0.255. 0.1.0.0. Okay. Again it will repeat 0.1.0.1. Same it is keep going like that. Okay. So 0.255.255.255.4. 0.255.255.255. Once it is completed, then it is start with the 1.0.0.0. 1 dot 1.0.0.1. Okay. Finally, we reaches 255.255.255. That is the total IPv4 range. Okay. The total IPv4 is divided into 5 classes. Okay. Class 1, class 2, class 3. Okay. So to identify an IP address, which class, sorry, that is I will tell again. Use first octet only. Okay, we use first octet part here. Yeah, I will tell the classes, guys. Guys, understanding? No one is speaking anything.
Yes, sir.
Because it's a kind of stuff. These IP address classes, it's it keep on going. But you have to interrupt me if you don't get it, or at least you should speak something to understand. So starting is first octet only we are considered. That is again I will explain. That is how to check which class of IP address it is. Okay, class A 0.0.0.0. Sorry. First octet I am writing in the binary format, that is 8 zeros. 1 octet means 8 bit. The starting is 0.0.0 is there now. First 0 you have to take it. This is the starting one. Okay. So that is what I am taken 0. And because of it is a first, class A is a first one. So what it is there? So first MSB, the first most bit, the first bit will be same. Remaining become ones. Remaining becomes ones. If you don't remember this binary kind of stuff, guys, no problem. Remember the range. Range is very important. So it is a 0 to 127 range it is. Okay. In certain test books, it will shows instead of 0, 1 or maybe 126. There is a reason behind it. Okay. What is the reason? Again, we can't assign some IP address. We can't assign some below IP addresses to our device. Our devices are NICs. Can't assign because it's a reserved IP addresses or something. First one is this is reserved IP address. Is a reserved kind of stuff. So use it for a certain services. Reserved IP address for use like a default routing configuration, DHCP, DORA process time. This will be used. DHCP client uses this kind of stuff like this. This is having certain purpose. So we can assign this series, and also this series also we can't assign. So we can't assign this series. Next 127 dot. This is much very interesting. Okay, this IP address also reserved IP address. This is a reserved IP address using for a local host. We call this one as local host or loopback IP address. Okay, we use it for a self-testing and accessing. So local IP. It's a local host, local IP address. Actually, there is some explanation. Yeah, I will tell normally, guys. I have a laptop. I want to access my remote PC. So, like, why my laptop is getting heated today? Okay, this is APC. This is BPC. Okay, BPC having some IP address, for example, 10.0.0.5, and APC having an IP address 10.0.0.4. Okay, from A to B, I'm pinging. For example, ping to B means which address? So what is this meaning? I'm communicating. I'm sending a ping request to B, right? So I'm trying to send a ping request to B. We receive it and it will send it back. Okay, so I'm communicating from one device to another device with a destination IP kind of stuff, right? For example, if I use ping in APC 127.0.0.1, okay, I am pinging to APC only. Okay, every PC, guys, every PC having a name, computer device name is there. Every device having a name, but all devices, I have 100 computers, each computer having a name, A, B, C, D name, for example. But all computers commonly same name is there, that is called a local host. My PC for local purpose, local host. For example, what is my name? I think you guys already forget. Okay, my name is Latif. When I'm telling about me, or when I'm talking to me, or when I'm telling about me, what I will tell? Myself, right? It is me, myself only. I'm talking to me. I'm think is like a so local host. I'm myself, me, yourself, you, right? Right. That's belongs to you only. So myself is same for everyone. Same way, each and every device has a local host name is there. That is called a local host. Okay. Second one. For example, here is a one server application. My database application is there, for example. And here is a database client is there. This is a server and a client. Both are in a same machine. I want to access from client to server from same machine. So you can use 127.0.0.1 or a name called a localhost because of both are in the same PC. For example, you want to access from here. So this is my database client application. I want to connect it to this server. Then which one I have to use? 10.0.0.5 means in the self you can use this, but when you are accessing from outside, so this you have to use the main IP address. Okay, it's little bit confusing, but remember 127.0.0.1 is a local host or loopback address, which is used for self testing, self self or a same device access. In same device. Okay. And also 127 dot this entire series is also we don't use it. Next important is we don't use class D and class E also. We can't assign class D, class E kind of stuff. We can't assign. Okay, I will write here. Okay, so next class B. So what is the next bit of this one, guys? It is 100 like this. Again, class B means it's a second one. So then I'm putting first two bits are not touching, remaining bits become 1. Of course, there is several reasons and all there, but you have to remember the ranges. Even binary also second part. The version is 191. Next class C. What is the next one is 11000000. This is also following next bit kind of stuff. Class C. It is a third one. So first three keep it like that. Remaining make it as a ones. 192. 223. 1110. This is the class D, right? Keep first four are same, remaining become 1. So 224, 239. Here it is no reserving, so completely you are taking 240 and 255. That is the last one. This is a class addresses. And why we should not use class D? Because it's a multicast address. Okay, multicast address. And class D is a reserved R&D. Reserved for R&D. It's a research purpose. They're kept aside. Okay, we don't use it. And class D is a multicast address, and we can't assign to any device used by certain services. Certain services. Example: EIGRP, RIP version 2, OSPF. They're all using multicasting IP address. Boot P protocol using bootp protocol, guys. It is used to deploy, or we can say install OS or applications through network boot type it is. Okay, through network to multiple devices at a time. And EIGRP OSPF RIP version 2, there are routing protocols exchange. Okay, EIGRP RIP version 2 OSPF exchange routing tables using a multicast address. You don't get it, no problem. Okay, so this is important. First important is, this is important, guys. It is a localhost loopback address used for self-testing, self-device accessing, self-device service access, or same device access. This is self or a in same device access. Self device or a same device service access mappers. Okay, so these are the things about your IPv4 ranges, guys. And IPv4 again not completed. This part is again is there. Just I will tell about few small points about IPv6. IPv6 does have this much of history. It is very simple one. So it is 128-bit, very big IP address range. So here if you see, I've written IPv4 from here to here, totally 4.3 billion. But IPv6 we cannot write like that because it's a billions, 10 to the power of 38. That many things you have to do it, and it is not like that. It is different one. Okay. So learning of IP address, their subnet mask is different from learning of IPv6 again. Okay, but both are almost like both are IP addresses, both are having their own properties. Both are used for a communication purpose. So this is represented in hexadecimal format, guys. One hexadecimal is 4 bits. Okay, one single hexadecimal is a 4 bits. We have 128. 128 binary bit. It is divided by 4. It comes with a 32 hexadecimals. 32 hexa numbers we are getting. For hexa always H is kept. Hexadecimal numbers, that is 32 hexadecimal numbers. Okay, so each 4 hexadecimal numbers divided into a block. 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 Each 4 hexadecimals into decimal. Sorry. numbers into a block. Okay, 4 4. So 32 by 4 means how many? 8 blocks are there. Totally 8 blocks separated by colon. Yes, colon, semicolon, colon, spelling correct. Okay. So you can see here it is. There is a totally 8 blocks. Each block is separated by colon. Okay. So that's the point. Of course, you have a different theme here, guys. It's a different ranges are there directly. Okay. So usage purpose. For example, you take a global unicast. It is a kind of public IP address. This is also written like a 001/3. Okay. /3 type kind of stuff. It will return, but try to understand. If you see any IP address is 000 starting like this. In this complete ranges comes under global unicast. Starting address either 2000 to 3FF, 2000 to 3FFF. This is global unicast address. Link local IP address. Link local address, it is there. Link local is generated by system based on analysis MAC address. Based on analysis MAC address, and how it is look like FE80::. Okay, so any IP address you have seen starting FE80, it is a link local IP address. Of course, it works in LAN communication. Means if you don't have any MAC address, sorry, you have NIC, IPv6 is enabled, you didn't configure IPv4, you have a 10 computers, all 10 computers don't have any IPv4, IPv4 is there or not, don't mind. No DHCP, nothing. Still we can able to communicate. No DHCP, still we can able to communicate in the LAN because of this is valid IP address within the LAN. Okay, so this is a point. Yeah, finally. Okay, there is two more kind of IP addresses are there, guys. So one is private IP address, also there. We have a private and multicast IP addresses also there. That is range. We can just FC80. One is FC80, another one is FD. One is FC, another FD. So just check it once. Go through any Cisco site and you will get it. Okay, find out other differences if you get. Guys, again, so IPv4 32-bit, IPv6 128-bit. IPv4 it's 4.3 billion IP addresses, IPv6 is 3.5, 3.4 into 10 to the power of 38, which is a billions of IP addresses. We write IPv4 in a decimal format. We write IPv6 in the hexadecimal format. IPv4 will write like this: 192.168.10.23. In IPv6, we write in a like this one. So something you can put a colons in between the four numbers, four numbers, hexadecimal numbers. So IPv4 actually divided into 4 parts. It's 32 by 4, 8 bits. These are 8 bit, we call it as octet. Each octet is separated by a dot. So 192.168.10.23. Like that you have to read it. Not point, guys, it is not point, full stop, not one, it is dot. Okay. So 4 octets, each octet size is 256, means the total octet range is 0 to 255. So we have 4 octets: first octet, second octet, third octet, fourth octet. Also we can represent them in a W, X, Y, Z, W dot X dot Y dot Z kind of stuff. Each octet is maximum size is 255. The total IP address range is 0.0.0.0 to 255.255.255.255. This total range is divided into 5 classes. Okay, class A, class B, class C, class D, class E. Okay, the class A range is 0 to 127, class B range is 128 to 191, class C range is 192 to 223, class D range is 224 to 239, class C range is 240 to 255. Class A is a reserved for R&D in future purpose. Still we are not using. And class D is a multicasting purpose. Multicasting means it is used for a certain type of services only. Class A, class B, class C, class A, class B, class A, B, C are belongs to unicast address. Class A, class B, class C are a unicast addresses. Next, we can't assign certain type of IP addresses to a device or NICs. One is 0.0.0. It is a reserved IP address for a certain services as well as 0 series. 127.0.0.1 is a local host address, loopback address, self-testing or self-device accessing kind of stuff we are using. It's a loopback purpose, right? This is a 127 series. Also, we don't use it. That's why I have written in a bracket 1 to 126 we are using. Okay, next, yeah. Actually this should be combinedly in one place. No problem. Yeah. In IPv4, local host, what is the local host address? 127.0.0.1, right? Now in IPv6, it is written like this: colon 1. What is the local host in IPv4? Remember, guys, this is 127.0.0.1 in IPv6 : 1. 0.0.0 is a unknown IP address or some zero address is like this. And coming to IPv6, this is represented as a : In IPv6, there is so many ways of writing IP addresses also. Okay, this is compulsory. Remember, something I'm missing from here. I didn't recollect, but I will give you some example, guys. Please, just 2 minutes. Then 2 minutes or 5 minutes, no problem. Then I will give you a small break. Okay, look at here. 12.0.78.120. No, not 120. It is 191. Okay, which class it is? Okay. So class A, class B, class C are unicast addresses which we are using, using in regular communication. Okay. Guys, tell me which class it is. What is this first octet? Look at the first octet. Okay, and go through this table. 12 means it is a class A. 120 dot 191 dot 12 dot 253. Which class it is? First octet means the W. Okay, and C table. Guys, are you able to hear?
Yes, sir.
Then tell me what is
Yes,
that class, which class it is? So see the first octet, only first octet, don't see the remaining thing. See the first octet. And remaining thing is also no octet is more than 255, right? It's not 256, 300, 400 is not there. So it is IP address is good. Okay, next one is to identify classes, you have to look at the first octet only. Okay, what is the first octet? 120. And where is the 120 here? In the range of this one only. So then it is a class A. Which class it is? You have to tell guys, otherwise I have to close the class.
Class B.
Very good. Class B. How? 137. Sorry, 134. 134. 134 is in the class B. If you don't remember that table also, no problem. Just try, just keep telling something. Then I can understand you are getting something. Now it is
Class B, sir.
B.
class.
Class B.
Check the first octet 149. Where is 149? Still it is class B only.
C.
Very good.
C.
Very good. Class C. So it is 201. 201 is in a class C. So class D, class C, also same thing like you just for our understanding. Okay. 225.0.0.
D.
Class D.
Yes, sir.
Very good. Two 49. Where is 249? In this range. Class
Class E.
E. Okay. So out of this one, class A, class B, class C, important because of daily we are using that one. Yeah, today we are all spending with only IP addresses only. But if you understand, that is important. If you don't understand, that is my trial is entirely. Once again, guys, what is an IP address? The question is, what is an IP address? Second is difference between IP address and MAC address. Difference between IPv4 and IPv6. How much you can able to tell about it, that much you can tell. I didn't go to depth of IPv6, just I trying to tell IPv4 only. And IP addresses, their classes and ranges, classes and ranges. And what is 127.0.0.1 are a loopback address, local host address. The question can be this to that, that one to this one. In IPv6, what is local host address? That is also good one. Okay. Okay. So next one is I am going to tell about a network and host portions and subnet mask also. So please be there and just okay. So just we'll take a break. Come back in 10 minutes. 12:20. So don't take much. It's 12:20 already. Come back by 12:30. 5 minutes, no problem. Plus 5 minutes, no problem.